I'll say it, you'll see it, is visceral muscle, visceral meaning, gut. And smooth muscle, this is the muscle which lines all the hollow organs in our body, like, well, like the intestines. And smooth muscle, the contraction of the smooth muscle is what's responsible for moving materials through the GI tract and, all that kind of stuff. So I don't know, I can tell you how many bones are in a human body, and you remember that as well. It's 206. The number of skeletal muscles in the human body seems to vary depending on how you count them. Is the longest and brevest of the peroneus one muscle or two muscles? So it can be a very large number, well over 800 or perhaps even more than that, depending on actually how you do the count. So there are a lot of muscles in there, that's for sure. Now, it's important to understand the characteristics, and we touched on this again earlier in the semester. It's important to understand the characteristics of muscle tissue. Skeletal muscle, very importantly, of the three kinds, skeletal muscle is voluntary. It does what you tell it to do, at least under most circumstances. It's under control, of course, the brain. It's voluntary. You might recall it has striations, those stripes in it. That's characteristic of skeletal muscle. And also, skeletal muscle is unusual in the sense that it is multinucleate. We typically associate one nucleus per cell, but because some muscle cells are so long, you need more than one nucleus. For example, if you can see Willard over there, there's a very long, the longest muscle in the body is a muscle that runs across the front of our thigh. It's the sartorius. It could be 3 feet long. That means the cells themselves are 3 feet long. It's not like 1,000 cells end to end that are 3 feet long, but the cell itself is that long. So, yeah, you need more than one nucleus in there. Cardiac muscle, now, cardiac is definitely involuntary. You can't tell your heart to quit beating. It does show striations, single nucleus per cell, and also the little structures you saw earlier in the semester, the little junctions between the cardiac muscle cells, the intercalated discs, which allows the muscle to contract as a unit. Smooth muscle, involuntary, no striations visible, single nucleus. So you can see that these two do have certain things in common, and this one's sort of the one that stands out because that's the one that is under our conscious control. So those are the characteristics of the three kinds of muscle. 4 features that I pulled out of the book to tell you about muscle tissue, and generally what we're talking about now is skeletal muscle tissue. Contractility. Muscles contract. They shorten and pull. That's how muscles do their job, right? They shorten and pull. So your muscle can contract. If you flex your bicep, it contracts. It gets smaller. It shortens. And you can, pull. Also, muscle tissue has a characteristic called excitability. It responds to a stimulus, basically an electrical stimulus from the central nervous system. But if you've ever made this mistake, and we probably all have at some point in time in our lives, have managed to give yourself an electric shock, right? You know your muscles will respond to that electric shock. That's, done that, right? Elasticity. Well, fortunately, our muscles are elastic. So after you contract it and relax it, it goes back to what it looked like before, right? So they rebound to their original shape after contraction. And this would be the same even, I'll just see if I can find that super sheet video. It would be the same like, bodybuilders, things like that. It's like, yeah, they got that, tremendous look. But when they aren't posing, they still have, a lot of muscular definition, but, the muscles do go back to whatever their original shape is. We have, I wonder if it's still here. Oh yeah, here it is. Some instructors actually will take pictures out of these magazines, but not me, right? And now I just want to point out to you guys that they photoshopped this. These are actually my abs, and they put somebody else's head on there. I just want to make clear that you believe that, right? I show you, except I look through this. Sometimes I'm giving an exam or something, I look through this and go, oh man, I mean, this guy's got some, I don't know. veins are going to just pop right into the skin. So we look through these every other page for some sort of supplement. I'll leave this up here in case. And the last one is extensibility. This is one that's a little harder to understand. The ability to contract over a range of resting lengths. The easiest way to understand it, and the simplest way, perhaps, is like, I remember my son saying, "Dad, show me your muscle," or something like that. And you go, "Okay, like this." Like, "Oh no, you can make a bigger muscle than that. You make it a little bigger." Like, "Oh, come on, it can be bigger than that, a little bigger." So it can sort of, extend over, a certain distance, and then it will go back, elasticity back to its original shape. So, you can really pump it or just kind of a little bit, right? So you get the idea of what extensibility is. So these are some characteristics of muscle tissue. In general, as I said, we're talking about skeletal muscle tissue. Now, functions. Well, not surprising. Not surprising, one of the major functions of skeletal muscle is movement. Absolutely. Moving the body, skeletal muscle. Another function of skeletal muscle, of course, is to maintain our posture. You probably want to get yelled at, but remember mom and dad going, sit up straight, you don't want to be slouching and stuff. And so our muscles do maintain our posture. Obviously, because we talked about articulations already, the muscles stabilize the joints. If you remove the muscles from the joints, you got nothing, right? So stabilizing the joints. Right, this one's obvious, of course, support for soft tissue. How to do that as well. And another one which maybe, you can certainly understand this, generation of heat. When muscles contract, they utilize a chemical called ATP to generate that contractile force, but they do also, your muscles, when you're exercising, we all know this, generate heat. That's why you're sweating when you're working out. Right? The muscles are contracting and generating heat. Now, this is actually important for maintaining, in extreme conditions, for maintaining body temperature, right? You all know that there's a condition called hypothermia, where the body core temperature, because generally speaking, you're usually wet and it's cold, and the heat's being sucked out of your body. One of the telling characteristics of hypothermia is uncontrolled shivering, because the body is trying to generate heat to stay warm. So, if you were out in an environment where a person got wet and cold and they just couldn't quit shivering, you've got to look at them and think maybe they're getting hypothermic. You've got to get them dry. You've got to get those wet clothes off of them and dry them up, right? Dry them out and put that body heat back in, because if the core temperature drops too low, death can result. Allison Green, our lab tech, when she was in grad school at USC, she had the opportunity to go to the Antarctic for some of the research she was doing. And I know this to be a fact because I know somebody else that went down there. And they fly to McMurdo, which is the main American base. And I've seen this on television. My nephew's gone through it. Allison went through it. It's called the Happy Campers something course. That's what it's called. And they have to teach everybody basic sort of survival on the ice. And Allison said they had to build an igloo. And she said she was working really hard and was sweating. And then as she cooled off, and Allison's not, she's a very small woman, she started to shiver, and because her clothes were wet from sweating, and somebody realized, oh my gosh, she's getting hypothermic. So, an uncontrolled shivering is generating heat, and you got to keep an eye on it.